Today we're looking at a special kind of probability distributions called binomial probability distributions. They have to have two possible outcomes. The trials have to be independent. There has to be a set number of trials, like you're flipping a coin 6 times or something, and the probability of success has to stay constant on all trials to be a binomial probability distribution. A little bit of notation, so S and F stand for your two outcomes, success or failure. P stands for the probability of success. So say if the probability of success is 0.7, that means the probability of failure is the other option, like 1 minus 0.7 is called Q, the probability of failure. N stands for the number of trials you're conducting in your procedure. So if it's like flipping a coin 6 times, N would be 6. And X is the specific number of successes you're interested in finding the probability for. There is a formula for it that is kind of crazy looking, but it is programmed in your graphing calculator. So you don't have to memorize it or anything, just have to know how to get to it in your calculator. So let's take a look at how you can calculate some binomial probabilities. So our situation, if you read through, is we're basically looking for the probability that if we pick 10 smokers, at least that 4 of them started smoking before age 18. So check to see if it meets your requirements first. There is a fixed number of trials because we're selecting 10 smokers. These should be independent because we're taking just 10 people out of all smokers. That's a small enough proportion of our population that we can treat it as independent. If we look, the only two options are people smoked before age 18 or they didn't. So there are only 2 possible outcomes. Anything with more than 2 possible outcomes is not a binomial distribution, and you're going to have to calculate your probability some other way, like listing it all out like yesterday. So it's a good idea to keep track of what you're considering a success and a failure. A success may not always seem like good. So a success is typically the outcome that you're interested in finding the probability for. So we want the probability that at least 4 of these people started smoking before age 18. So we're going to consider a success getting a person who did start smoking before age 18. And a failure is that we don't get someone who meets that requirement. So you need to run through all these different requirements before you use the binomial formula to do your calculations, or your results might not be valid. Last thing is our probability of success fixed. Yes, it's going to remain 80% for each person that we select. So notation-wise, N is the number of trials, so we're selecting 10 people. So going and making 10 selections, N is going to be 10. X is the number of successes we're calculating the probability for, so we're looking for the probability that 4 of these people started smoking before age 18. The probability that we get someone who meets that requirement is 80%, and then the probability we do not would have to be 20%. So let's calculate some probabilities. The probability that we actually wanted, probability that exactly 4 people started smoking out of these 10 before age 18. You can use that formula that is programmed as a function in your calculator. You have to make sure that you enter the arguments into it in the right order. So the first thing you would do is your number of trials, then your probability of success, and finally the number of successes you want to calculate your probability for. Okay, so the binomial probability formula is programmed into your calculator. So how you actually get to it is you hit your second button, and then you go to the variables button and hit it. And then you want to scroll all the way down until you get to A, which is binom PDF. And then go ahead and hit enter. You will have to type it in the correct order. So first we need our number of trials, which in this case is 10. Gonna have to do comma. Next comes your probability of success, which for us was 0.8. Another comma. And then the number of successes we're trying to calculate the probability for, which was 4. Hit enter. And this one is like 0.5%. You can also use this table in the back of your book to calculate probabilities for binomial distributions. So if we want the probability that we select 7 or more people who started smoking before 18 in our group of 10, we do probability of 7 plus probability of 8 people plus probability of 9 people, and so on until we reach our max. So you could calculate those probabilities individually using your graphing calculator, but it would kind of be a pain to do it that many times. So if you look at this table, find the correct number of trials, which is 10, and then we're interested in the probability that 7, 8, 9, or 10 people started smoking before they turned age 18. Our probability that that happened is 80%, so we'll want to find the column with the correct probability of success, so 0.8. And then if you go across and read where that column intersects at, you will have the individual probabilities that like 7 smokers started before 18, 8, 9, or 10. And then we'll just add them all up to get our probability of at least 7 people started smoking before 18. So if you add up all those probabilities that we just found using your table, note that this is a little bit easier than typing that all into your graphing calculator and doing 4 different calculations. The table is kind of handy sometimes. It takes me a second to write these down here. But if you add them all up, your probability is going to be 0.876. C is kind of similar. You want the probability of selecting 5 or fewer people who began smoking before age 18. So that's the probability that 5 or 4 or 3 or 2 or 1 or 0 people started smoking before age 18 in this group of 10 that we've selected. Sometimes people forget to do the 0, so make sure that you remember that's an option. I would again go back to your table for this calculation and look them up. So if you go back to your table and get your values and jot them all down here, you're going to come up with a probability that's pretty darn small. We're going to come up with a probability that's pretty darn small. There's only like a 3.3% probability that we get a group of 5 or fewer smokers out of our 10. So this situation, not quite so broken down for you. We want the probability that we accept the shipment of pills if it is going to be accepted if only 1 or fewer tablets do not meet required specifications. So there's a couple different ways you could look at that. I would think about it as we will accept it when 1 or 0 tablets have defects, which means we could calculate the probability that X is less than or equal to 1 if we consider that being defective our success. So if you jot down a few things so you're keeping track of what's what, we're selecting and sampling 24 tablets, so N is 24. If we're thinking about a success being a defective tablet, that'd be 4%. And then X, our probability number of tablets that are defective that we're interested in selecting, would be either 0 or 1. You could calculate this in your graphing calculator using that binomial probability distribution function. And if you do that, you'll have to do it a couple times. So you could do it for 1, you could do it for 0, and then you could add those two defective those two probabilities together. Oh, I wrote this out of order compared to the previous line, but I'll change it here in 1 second. Sorry about that. So you'll have those two individual probabilities that you can add together. You can type this all in one line in your graphing calculator if you want to, or you can do like equals on one and then use like answer and then plus and then do the next one. We get a 75% probability.